Okay, so last recording was actually I recorded maybe an hour video, but I ended up messing the recording, so it didn't have sound, and it was a bit. It was also cut before the end. So that's pretty bad. But fortunately, there was not. This was not a super important video, I would say. More like a rework of what we went so far, right? So let me summarize what went wrong. The first thing that happened was that I revisited the real-time update feature. Basically, the fact that when we launch application, as I said that you can change the somebody can change entries in the map, in the user list, and the configuration of the application, and it would be automatically reflected on the other connected front ends. So I thought about it, and it turns out that I think it's kind of strange. It's strange because most other applications don't work this way. Right? If you have a configuration panel on something, you work on changing the settings, you don't want to have the view that your current view change as you are working on it, right? It's much more natural to have an isolated view, do all the edits, and then commit. And if you have a conflict, then you retry, right? So it's simpler both from the architecture point of view and from the user experience to have a refresh button, right? Refresh button and refresh shortcut. So that was one direction, one change we were gonna make. The second change was about the serialization. Since now the application is it's pretty much a web application, right? Well, the front end is not a web client, but it's a desktop application that connects to a backend and does request response type of commands. So the backend is no longer live pushing data to the front end. What we have is it's a pure web-like model. I know the front end is not a web application, but it could very well be. So our backend is going to be a web service, and this way it could be integrated with other applications fairly easily. And as a web application, using protobuffer as a serialization format is not optimal. It would put a unnecessary burden on the other clients to use that library. And the advantage of using protobuffer, which is mainly structured schema, efficiency of the payload. This data size is potentially smaller. Maybe also the speed of serialization and deserialization. All these advantages are not that significant in our context, because our context is a management application. We don't expect to have thousands of, even 1,000 users would be fine, right? The payload will still be under 1 megabyte. So 1 megabyte over the LAN is totally insignificant. Well, it's not insignificant, but it won't break the user experience. So as a conclusion, I migrated to JSON. So to do that, I removed the dependency on protobuffer, and so this project test serialization is gone. And I looked for a library that can do serialization, deserialization from F# records, and the one that I found was JSON.NET. Right? So it's like the first hit, and JSON.NET works with C# classes, but also F# records. F# records are actually implemented as classes in the generated assembly, but we want something that can natively support records, so that the mapping between them and the JSON string is natural. Because on the other end of the receiver end, which is the backend, is written in Clojure, so not a .NET based framework. So we can't use the same library to deserialize, right? And if the mapping has some implicit rules, these rules will have to be recoded in Clojure, and we don't want to do that, right? So the idea now is so we switch to JSON, and also when we switch to JSON, we remove the aggregation that happened in the parent. So before, the record had a parent as a record, and it turned out it was pretty obvious, I guess, but I didn't see it. It was pretty bad serialization, because you aggregate the parent in every child, right? So if you have a tree that then the parent will be present at every level. So basically, the root of your tree will be present in every node, right? And even more than that, because all the intermediate nodes will be repeated in all the children. So that compounds exponentially. And there's no real value to that. So instead, well, I guess the real value to that is that you can take one piece of your data and still treat it as a full. All the information would be there, right? There's a self-contained property to every node, but the overhead is astronomical, right? So that's totally not worth it, since we're not going to use this property even. So instead, the parent is now a string which refers to the name of the parent, right? And if you are on the root node, then the parent will be a blank string, right? So we make sure that there's no null. Names cannot be null, and parents can be null. Only reserve value will be the empty string. So the name cannot be empty, because an empty name refers to the root node, or to the implicit root parent. So other than that, we just refactored a little bit the application. Another thing that happened was the user list item that was inside interfaces, which was a row of the is this application still here? Yeah, a row of the tree list view is no longer in interfaces, right? It was I said when I put it there that it didn't seem very natural to have it there, and the reason was that it's a view model specific type that we needed for the mapping to the DevExpress control, right? DevExpress control expects a particular layout of every row. That class was actually pretty much the same as our user record, but it had a mutable field for the name, because we want to be able to edit the name. So now we actually have two. We have the user record, which is a serializable to JSON and back and forth from JSON type record, and we have the user panel has also a user list item, has kind of the same as with a mutable field. So it's a bit overhead, because since these types are different structurally because of the mutable part, you can't convert implicitly in F#. So I have written those two helper functions that does this conversion, and you can see that it's pretty straightforward, right? You copy one field to the other. And if we were fancy, we probably could use a macro type provider to do this for us. But that goes beyond the scope of this project. So for the time being, we do the conversion manually, and well, it's not that much code to type. It feels redundant. But the advantage of that now is that in the future we will be able to add entries to our base interface, our user record, and you notice that currently the user record doesn't have the settings, right? So if the backend will sense the settings as part of the user record payload, and I think it makes sense to do that. We will be able to change the user record data model inside the interface without touching the user list items, which is the right thing to do, right? User list item is bound to only the left side of the view, right, of the UI. So it shouldn't have any settings in there. So we keep entries and types specific to that domain. Right? The user list item is specific to the user list, so it doesn't have any settings. Whereas the user record is actually going to be our all information we need for a given user. So that includes the settings. Alright, so yeah, that's it. You didn't miss much, but I would be more careful and make sure that all the recording works next time. Thank you.